Today we're going to be working on how to evaluate piecewise defined function, and to be able to identify or evaluate piecewise defined function, you should know how to identify the graph of some basic or common function. You should also know how to read inequalities and to be able to graph functions given by f of x. Now, some of the common functions that we're going to be seeing and using in our piecewise defined function are some linear function given by y equal to x, and sometimes we'll also be given by y equals x squared, or a parabolic function, and sometimes we'll have function with a cubic function, or y equals x to the third power, which gives you a graph that looks like this. So it's extremely important that you know how to visualize these particular graphs, because sometimes we'll be using all these graphs in one function, and sometimes we'll be able to read it by just visualizing the graph that we are given in some piecewise defined function that we're going to be using in this problem. So let's say, given a piecewise defined function of f of x equal to x and x squared, where x is true for x less than or equal to -2, and for values between -2 and 2, the function that we are going to be using, or the formula we're using, is x squared. Now, you will see in the graph in this piecewise defined function that we have a linear function and a parabolic function. But this particular function is only true given the limits, or the inequalities, or the range of values of your domain for this particular example. Now, if we're going to be partitioning our piecewise defined function, we have a partition here at x equal to -2, wherein to the left of -2, the function that we're going to be using will be the linear function f of x is equal to x, and for any values of x in between -2 or -2 and +2, we'll use the function x squared, which is the parabola. So by evaluating these functions starting with f of -4, all we need to do is to find the value of y at x equal to -4. And at x equal to -4, you will see that the y is existing at y equal to -4. Therefore, when x is equal to -4, y is equal to -4, so f of -4 is equal to -4. So to evaluate the functions that you're seeing right now, it's basically finding the value of y, or the height of the function, given x. So at x equal to 0, x is equal to 0 is somewhere here in your x-axis, wherein it falls under the parabolic function x squared, and in the parabola, it's touching y equal to 0, so at f of 0, the value of our f of 0 is equal to 0. And at f equals, or f of -2, so when x is equal to -2, it will only be true for the linear function, because for the parabolic function, -2 is not included. So at x equal to -2, our function is going to equal to -2, because that's when x exists in our function. So f of -2 is equal to -2. And for f of +2, here is x equal to 2. You will see that the function is true at y equals 4. So it exists. So we have f of 2 equal to +4. Now, the last example, which is f of 4, we're looking to find, or we're finding the value of y at x equal to 4, and you will notice that there's no function, or there's no value of y in, or at x equal to +4. So in this case, f of 4 does not exist. So this is how we evaluate function given a piecewise defined function and its graph. Now, in most cases, or in some cases, the graph of the piecewise defined function is not given. Let's take a look at this example where f of x is given by -2 minus x, x squared minus 3, and 10 minus x cubed. The range of values is also given, so when you are going to evaluate f of -3 up until f of 2 for this particular problem, you will need your xy plane. So I highly suggest that you just draw the xy plane so that you'll be able to visualize which formula or function that you need to use at the given value of x. Now, there are three partitions in this particular region. We have anything to the left of -1, anything in between -1 and 2, and anything to the right of 2. Now, to the left of -1, the function that we are going to be using will be -2 minus x. Now, anything between -1 and 2, not including -1, we will be using the function x squared minus 3. And at any value of x that is greater than 2, we will use the function 10 minus x cubed. So now that we're able to identify the specific function that is true for that range of values, we are now ready to find the value of each function that you are seeing right now, starting with f of -3. So at f equals -3, we know that x equal to -3 only works whenever the function that we're using is the blue area of the xy plane, which is -2 minus x. So we will use -2 minus x as our function at x equals -3, and by direct substitution at f equals -3, the function is equal to 1. And at f of 1, where x is equal to +1, we will be using the pink region, which is in between -1 and +2. Therefore, x squared minus 3 is the formula that we are using. And by substitution, f of 1 is equal to -2. And for f of 3, we're going to be using the formula in the green region, or anything higher than 2. So we will use 10 minus x cubed. And by replacing 3 to x, we'll have -17 as the value of f of 3. And for f of -1, now -1, as we know, is in the blue region, because at -1, at exactly -1, we're not going to be able to use x squared minus 3 because it's not included in our domain or x value for this particular function. So we will be using the formula to the region, or to the blue region, which is -2 minus x, and by direct substitution it will equal to -1. And for f of 2, we will be using x squared minus 3 because +2 is in between -1 and +2. So by substitution, x squared minus 3 using the value of 2 will have 1 for f of 2. So this is how we evaluate a piecewise defined function. And to be able to understand piecewise defined function, you need to know how the function behaves, and you also need to visualize the range of values where x is true. So if you liked and learned something from this video, please like, share, and subscribe to my channel. Thank you.